chemical equation, it is a symbolic representation of a reaction. Let us take one example. Methane, the formula of which is CH4, reacts with oxygen, that is O2, to form carbon dioxide CO2 and water H2O. This is a skeletal equation. If the equation contains same number of atoms on both sides of the arrow mark, it is said to be balanced equation or stoichiometric equation. Now, look at here, both sides of the equation contains only one carbon atom. 4 hydrogen atoms are in the left side, whereas here it is only 2. So, put 2 before this H2O, the number of hydrogen atom is balanced. Now, what about oxygen atom? 2 plus 2 on product side, that is 4 oxygen atoms. In reactant side, only 2 oxygen atoms. So, put 2 before O2. Now, the equation is balanced equation or stoichiometric equation. If the balanced or stoichiometric equation includes the enthalpy change also, this equation is called thermochemical equation. So, if the equation includes enthalpy change of a reaction, delta HR, enthalpy change of this reaction, it is called thermochemical equation. For this reaction, the enthalpy change is minus 87.78 kilojoule per mole. So, this is a thermochemical equation. Now, some conventions are adopted to write this thermochemical equation. What are the conventions? First one, the coefficients in the equation before the reactants and products indicates the number of moles of reactants and products. Coefficients in the equation represents the number of moles of reactants and products. Then delta H value, that is enthalpy change value, should be given with proper sign and proper unit. So, the delta H value should contain proper sign and unit. That is the second point. Then, if the equation is reversed, that is reverse of the equation, let us write the reverse of the equation. CO2 reacts with 2H2O to form CH4 and 2O2. If the equation is reversed, the delta H value should be given like this. That is, the sign should be reversed. The negative sign should be now positive. The sign should be inversed, but not the value. The magnitude of the delta H value should not be altered. If the equation is reversed, delta H value sign should be reversed, but not the magnitude. Then the physical state of the substances, physical state of the reactants and products should be specified in the brackets. Say for example, for solid the letter should be S, and for liquid L, for aqueous AQ, and for gases G should be given in the bracket nearby the reactants and products. Let us write this. CH4 is a gas, so put G here. Oxygen is also a gas, carbon dioxide is gas, and water is liquid. Similarly, carbon dioxide is a gas, water, liquid, CH4, gas, and Oxygen is a gas. What is the purpose of mentioning this physical state here? The delta H value of a reaction depends upon the physical state of the reactants and products. So, in a thermochemical equation, the physical state of the substances should be mentioned. Then next point, for any calculation purpose, if the whole equation is multiplied by some number, the delta H value also should be multiplied. If the equation is multiplied throughout by a number, the delta H value also should be multiplied by the same number. And finally, if the delta H value is given with negative sign, it indicates the reaction is exothermic reaction, and if it is positive, the reaction is endothermic reaction. Do you know what is endothermic and exothermic process? If the reaction proceeds with the liberation of heat, it is exothermic, and if the reaction proceeds with absorption of heat, it is endothermic. And the endothermic reaction is denoted by positive delta H value, and exothermic reaction is denoted by negative delta H value. So, by keeping all these points in your mind, you can easily write the thermochemical equation for any reaction.